Hello students, in this e-lecture we will discuss a very important concept, total probability and Bayes theorem. But before that, let's understand what is partition of a sample space. A set of events E1, E2 and so on En is said to represent a partition of the sample space S. If number 1, all these events E1, E2, E3 and so on En are pairwise disjoint, means E1 intersection E2 is empty, E2 intersection E3 is empty, E1 intersection E3 is empty and so on. Number 2, all these events are exhaustive. It means union of events E1, E2 and so on En is equal to sample space S. It means probability of E1 plus probability of E2 plus so on probability of En equals to 1. And number 3, all these events have non-zero probabilities, means PE1, PE2 and so on PEN are always greater than 0. As an example, we see that any non-empty event E and its complement E dash form a partition of the sample space S, since they satisfy E intersection E complement equals to empty and E union E complement equals to sample space S. Students, always remember that the partition of sample space is not unique. There can be several partitions of the sample space. Now, theorem of total probability. Let E1, E2 and so on En be a partition of the sample space S. It means E1, E2 and so on En are pairwise disjoint and their union is equals to sample space S. Also, probability of each event is non-zero. Let A be any event associated with S, then total probability of event A is PA equals to PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus so on PEN multiply PA given En, which can also be written as summation of Pej multiply Pa given Ej, where j is from 1 to n. Students, here A can be any event associated with S. As S is sample space, so A intersection S equals to A. Now, E1, E2, E3 and so on En be a partition of sample space. Therefore, S equals to E1 union E2 union E3 and so on union En. By distributive property of sets, this is equals to A intersection E1 union A intersection E2 and so on. Students, you can understand it with the help of this figure also. Now, PA equals to probability of A intersection E1 union A intersection E2 and so on union A intersection En. All these are disjoint, so it is equals to PA intersection E1 plus PA intersection E2 plus so on PA intersection En. Now, by multiplication rule of probability, we have PA intersection E1 equals to PE1 multiply PA given E1, PA intersection E2 equals to PE2 multiply PA given E2 and so on PA intersection En equals to PEN multiply PA given En. Therefore, PA equals to PE1 multiply PA given E1 plus PE2 multiply PA given E2 and so on PEN multiply PA given En. Students, let's discuss some questions of Total probability. First question. Two-thirds of the students of a class are boys and the rest are girls. It is known that the probability of a girl getting a first class marks in board exam is 0.4 and a boy getting a first class marks is 0.35. Find the probability that a student chosen at random will get first class marks in exam. Students, we need to find probability that selected student gets first class marks. There are two types of students, boys and girls. So selected student who gets first class marks in exam can be a boy or a girl. So let E1 be the event that selected student is a boy and E2 be the event that selected student is a girl and A be the event that selected student gets first class marks. So we need to find probability of event A. As event A is connected with both the events E1 and E2, so by the theorem of probability, PA equals to PE1 multiply PA given E1 plus PE2 multiply PA given E2. Now, PE1 equals to 2 by 3 because in class 2/3 students are boys. Now remaining 1/3 are girls. So PE2 equals to 1 by 3. Next, PA given E1 equals to probability of a boy getting first class marks equals to 0.35 given, which is equals to 7 by 20. Similarly, PA given E2 equals to probability of a girl getting first class marks equals to 0.4 given, which is equals to 2 by 5. Now substitute the values in the result of PA. We get PA equals to 2 by 3 multiply 7 by 20 plus 1 by 3 multiply 2 by 5 equals to 7 by 30 plus 2 by 15 equals to 11 by 30. Take one more question. Students, read this statement carefully. In this question, an urn contains 5 red and 5 black balls. 2 balls are drawn. Here we need to find probability that the second ball drawn is of red color. So it's very much clear that first ball drawn can be red or black. Also, according to question, 2 balls of that color be added in the urn before second ball is drawn. So, let E1 be the event that ball drawn in first attempt is of red color and E2 be the event that ball drawn in first attempt is of black color and A be the event that ball drawn in second attempt is of red color. We need to find PA and by theorem on total probability, PA equals to PE1 multiply PA given E1 plus PE2 multiply PA given E2. Now, PE1 equals to 5 by 10 equals to 1 by 2 because urn contains total 10 balls out of which 5 are red. Similarly, PE2 is 5 by 10 and that is equals to 1 by 2. Next, PA given E1 equals to probability of getting red ball in second draw given that ball drawn in first attempt is also red. So according to condition, 2 red balls are added to the urn, then urn contains 7 red and 5 black balls. So PA given E1 equals to 7 by 12. Now PA given E2 equals to probability of getting red ball in second draw given that ball drawn in first attempt is of black color. So 2 black balls are added in the urn. Then urn contains 5 red and 7 black balls. And then probability of A given E2 equals to 5 by 12. Now substitute the values. We get PA equals to 1 by 2 multiply 7 by 12 plus 1 by 2 multiply 5 by 12. Solving it, we get PA equals to 1 by 2. Now we are going to discuss about Bayes theorem. Consider that there are two bags, 1 and 2. Bag 1 contains 2 white and 3 red balls and bag 2 contains 4 white and 5 red balls. One ball is drawn at random from one of the bags. Students, we can find the probability of selecting any of the bags, that is 1 by 2. Probability of drawing a ball of a particular color, say white, from a particular bag, say bag number 1, that is 2 by 5. In other words, we can find the probability that the ball drawn is of a particular color if we are given the bag from which the ball is drawn. But can we find the probability that the ball drawn is from a particular bag, say bag number 2, if the color of the ball drawn is given? Here we have to find the reverse probability of bag 2 to be selected when an event occurred after it is known. Famous mathematician John Bayes solved the problem of finding reverse probability by using conditional probability. The formula developed by him is known as Bayes theorem. Students, we shall now state and prove the Bayes theorem. If E1, E2 and so on En are n non-empty events which constitute a partition of sample space S, that is E1, E2 and so on En are pairwise disjoint and E1 union E2 and so on union En equals to S, and A is any event of non-zero probability, then probability of Ei given A equals to PEI multiply PA given EI upon PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus so on PEN multiply PA given EN. Students, by formula of conditional probability, we know that probability of EI given A equals to PA intersection EI upon PA. Now, by multiplication rule, PA intersection EI equals to PEI multiply PA given EI, and by the theorem on total probability, we write the value of PA as shown. So we get probability of EI given A equals to PEI multiply PA given EI upon PE1 multiply PA given E1 plus PE2 multiply PA given E2 plus so on PEN multiply PA given EN, where I equals to 1, 2, 3 and so on up to n. Students, while solving the questions, we use this formula of Bayes theorem directly. Let's discuss one question. Students, read this statement carefully. Bag 1 contains 3 red and 4 black balls, while another bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. Here, we need to find probability that ball is drawn from bag 2 and it is given that ball drawn is of red color. Let E1 be the event of choosing the bag number 1, E2 be the event of choosing the bag number 2 and A be the event of drawing a red ball. As there are two bags, so probability that bag number 1 selected is PE1 equals to 1 by 2. Similarly, PE2 is also equals to 1 by 2. Now, PA given E1 equals to probability of drawing a red ball from bag 1. As bag 1 contains total 7 balls, out of which 3 are red. So PA given E1 equals to 3 by 7. Next, PA given E2 equals to probability of drawing a red ball from bag 2. As bag 2 contains total 11 balls, out of which 5 are red, so PA given E2 equals to 5 by 11. Now, the probability of drawing a ball from bag 2, being given that it is red, is PE2 given A. By using Bayes theorem, we have PE2 given A equals to PE2 multiply PA given E2 upon PE1 multiply PA given E1 plus PE2 multiply PA given E2. Substitute the values of the probabilities. It is equals to 1 by 2 multiply 5 by 11 upon 1 by 2 multiply 3 by 7 plus 1 by 2 multiply 5 by 11. Now simplify it as shown. After simplification, we get probability of E2 given A equals to 35 by 68. Now, home assignment. Revise all the concepts which we have discussed in this e-lecture. Also try to solve question number 1 to 5 of exercise 13.3. In next e-lecture, we will discuss more questions based on Bayes theorem. Thank you.